Hi, I'm Pat Hinton with Microwave Journal. I'm here at IMS 2025 in San Francisco, talking to Navneet in the Anritsu booth. So you have a new true bistatic measurement technique. Could you tell us about that?
Yes, definitely. Thank you, Pat, for the introduction. Yes, this time at IMS, we are introducing a new measurement methodology or technique, which we are calling as a true bistatic RCS measurement, and I'm going to run through a demo. So this time at IMS at Anritsu, we are introducing a new measurement methodology called as true bistatic RCS measurements, which is based on Anritsu's PhaseLync technology enabled VNAs. We've been talking about the modular distributed VNA for many IMSs in the past, and it's just a repetition here, but these are the two VNA heads which can be separated out by a distance of 100 meters basically in an outdoor or an indoor environment, and they can make vector corrected S parameter measurements again up to 100 meters. Just to showcase you how the two VNAs can be separated out in distance, these are the two tethered cables assemblies, and you can space the two VNA out by more than 100 meters actually. These are not RF cables, these are only control cables, so that way your entire dynamic range is conserved. So in the new true bistatic RCS measurements, we have actually collaborated with a company called as JDI, and this is their RIS reconfigurable intelligent surface. And in this demonstration, what we are trying to showcase is this is the transmitter. It sends a signal to the RIS. RIS, because it can steer the beam in whatever direction you want, it steers the beam, and the reflected signal or the deflected signal comes to the receiver. So just if you look at the screen here on the software, we can control this RIS using an app which you can see here. So right now our baseline is set to 5 degrees. So the signal goes from VNA port 1, hits the RIS, gets deflected at an angle of 5 degrees, goes to the receiver. And that is a normalized 0 dB level. Now, if I change the beam a little bit, and you can see the change on the VNA level itself. So this is 10 degrees, I switch it back to 5 degrees, which was my original place, and you can see that it goes back to 0 dB. Now, the true bistatic RCS measurements are very important, especially for aerospace and defense customers and equipments like RIS, because traditionally the only way to do RCS measurement was either monostatic, where you just see the reflected signal which comes back directly to the same VNA source and receiver, or you were able to make some small distance between the transmitter and the receiver. That was called as pseudo bistatic. This solution, because we can separate the transmitter and the receiver by huge distances, is the only solution in the world that can do true bistatic RCS measurements. If you have more questions, please visit our website or reach out to me, navneet.kataria@anritsu.com, and we'll be able to help you more. Thank you so much.